All right, we're going to go ahead and get started. Hello, everyone, and welcome. Thank you for choosing to spend your valuable time with us. Today's webinar will cover Securing the Future, wolfSSL Solutions for NXP IIoT Edge MCX MCU Portfolio, presented by software developer David Garske and security project manager Stella Orr. My name is Emma, and I will be moderating the webinar. All attendees will be in listen-only mode. If you have questions, please use the Q&A box. After the presentation, David and Stella will answer your questions. As always, our webinars are recorded and made available on our YouTube channel. If you'd like to stay updated with all the latest from wolfSSL, follow us on X, connect with us on LinkedIn, and subscribe to our YouTube channel. Feel free to contact us via email at facts@wolfssl.com if you have any further questions. Before we dive into the technical presentation, I'd like to provide a brief overview of wolfSSL. Today, wolfSSL secures over 5 billion connections. We have more than 2,700 OEM customers and dozens of resellers. wolfSSL consists of over 50 dedicated employees, primarily engineers. This progress is, of course, supported by a strong partner network that we are very proud of. Since the beginning, our engineering team has developed several embedded security products, including wolfCrypt with DO178 support, a FIPS 140-3 certification, and a FIPS-ready offering, MQTT up to the V5 specification, SSH v2, TPM 2.0, a secure bootloader known as wolfBoot, Java wrappers and JSSC support, and commercial support for curl, and our newest product offering, wolfHSM. These offerings are accompanied by thorough maintenance and support plans up to the 24/7 level. We also offer full-service consulting. Now, I'd like to turn it over to David and Stella to discuss Securing the Future wolfSSL Solutions for NXP IIoT Edge MCX MCU Portfolio.
Thank you for joining us today for this webinar. My name is David Garske. I'm a senior software engineer at wolfSSL. I'm joined by Stella Orr, who is a product manager at NXP, working in Secure Connected Edge. And today we're going to talk about Securing the Future, wolfSSL Solutions for NXP Industrial IoT Edge MCX MCU Portfolio. That's a mouthful. Our agenda is this. First, we're going to cover security regulation updates and standards. Then Stella's going to talk about Secure Boot and the chain of trust and go over the MCX MCU portfolio. And then I will talk about our wolfSSL security solutions, our libraries and products. And there'll be a demo on the wolfBoot, MCX A15, and also a demo in the App Code Hub for wolfSSL TLS 1.3 on the MCX in 947, followed by a live Q&A. So first I wanted to go over US federal government requirements. So there's a couple of things that are new, relatively new. One is the FIPS publication 140-3, which defines new security requirements for cryptographic modules. So any products sold into the US federal government that contain cryptography must comply. And that can be hardware or software-based cryptography. The old 140-2 is end of life, and the 140-3 is in effect as of September 2026. The process of getting a FIPS certificate can take a few years. It's quite difficult. If you're using our existing certificate for our wolfCrypt FIPS, it's quite easy. You can do it in just a few months. I'm basically adding your environment to our certificate. Our module is a level 1 module, which means it's software only. We do have customers that support level 2 and 3. So you would take your specific hardware and we would introduce those requirements. So level 2 and 3 are basically tamper resistance and how to make sure the keys are protected physically. We're also planning a new FIPS certificate that includes key derivation and some additional AES modes. And beyond that, we're working on introducing post-quantum into the FIPS boundary. So that would be all the ML-Chem, ML-DSA, LMS, and XMSS verification modes. Also, let's talk about CNSA 2.0 and its timeline. So this defines new minimum algorithm strengths and timelines for transitioning to quantum-resistant algorithms. So as you can see, even in 2025, there are new requirements in effect for signing firmware with post-quantum resistant algorithms. And now Stella's going to talk about Cyber Resilience Act and a bunch more.
Thank you, David. Hello, everyone. Apart from FIPS 140-3 certification, there are some security regulations being launched these few years in the market. And these regulations ask digital product manufacturers to design their products with security in mind. It is the obligation of product manufacturers to design secure products for their end customers. So the Cyber Resilience Act and US Cyber Trust Mark are the two regulations getting a lot of attention now. So let me talk about each of them. The Cyber Resilience Act is the first European Union-wide legislation. It introduced mandatory cybersecurity requirements for hardware and software products throughout their whole life cycle. In the US, the Cyber Trust Mark is a voluntary labeling program for smart devices that help consumers identifying secure devices and choosing secure products for their homes. There are other regulations emerging, such as PSTI in UK. It comes to effect in April 2024. It also asks manufacturers to adopt security on smart products and also telecommunication infrastructure. Here shows a side-by-side comparison table of US Cyber Trust Mark and CRA. Both regulations pursue the same goal, that is to secure the IoT ecosystem and to provide a safer and more secure user experience for consumers. Although the regulations share the same goal, the scope, definition of products, and requirements are different. US Cyber Trust Mark is a voluntary program launched in January this year for digital devices selling to the US. It applies to consumer wireless IoT products. Examples of eligible products include internet-connected home security cameras, smart appliances, fitness trackers, garage door openers, and baby monitors. However, it doesn't include medical devices regulated by the FDA. Wired devices, non-consumer products, personal computers, smartphones, and routers are not included in the Cyber Trust Mark scope. The conformance requirements is based on NIST 8425. Cyber Resilience Act is a mandatory program launched last year for digital products selling to the EU. It is going to be full enforcement in 2027. So we have less than 2 years to prepare for the change. The CRA applies to finished products with digital elements, including software or hardware subcomponents. Automotive and medical devices are not included. It has a broader scope comparing with US Cyber Trust Mark. Smart TV and smartphone, industrial PLC are the examples of the products requires CRA compliance. CRA is also a labeling program. For a product that is compliant with CRA, it is allowed to put a CE mark on the product to show its conformance. However, for non-conformance product, there's a penalty. The fine is either 15 million euro or 2.5% of annual turnover. The conformance requirements is based on the essential cybersecurity requirements. Here shows the high-level regulation requirements on the left. The requirements can be divided into 7 categories. On the right-hand side, it shows the mapping of NXP EdgeLock security solutions to each requirement. The regulations requirements include product configuration, product authentication, access to the products, data protection, and so on. The combination of these NXP security functions allows our customer to address different aspects associated with the requirements. As an example, secure product configuration can leverage secure boot and secure update features, complemented by device lifecycle management, encrypted and secure install of software and secret keys. Another example, to fulfill the product authentication requirement, NXP provides hardware-based authentication, crypto processing, and credential isolation in our processors. We also provide trust provisioning solution so that root of trust credentials and OEM credentials are securely injected to our chipset during manufacturing process. Furthermore, NXP provides key management services so that keys and certificates can be managed remotely for the products in the field. Let me introduce NXP EdgeLock Security brand to you. Our EdgeLock security solutions are designed to address different aspects of security regulations and certifications. From the top, we have EdgeLock Assurance Program. It ensures our components are developed with security by design in mind and follow security maturity process, which is IEC 62443-4-1 certified. In the middle, we have EdgeLock Secure Enclave, Accelerator, Secure Elements, and Authenticators. These are enhanced hardware protections that establish system resources isolations to minimize risk of retrofit. At the bottom, it is our EdgeLock to-go services. With NXP secure provisioning tools, product manufacturer can connect to EdgeLock to-go services remotely and perform key management and device provisioning remotely. Out of all the regulation requirements, secure boot and secure update are the most critical security protections to preserve device integrity and prevent hackers injecting unauthorized software and taking control of the digital device. Authentication during device boot up and update is mandatory. To authenticate the software, the ROM bootloader in our processor verifies the digital signature of the software being executed and updated. If there is a security incident, our processor can recover from the attack and roll back to a safe state. Apart from preserving device integrity, we also need to preserve the root of trust of the entire system. A secure processor is the root of trust of the entire system. Secret keys and sensitive information are securely stored in the processor. With secure bootloader running in the processor, the root of trust is extended from the processor to an outer layer. For example, in this diagram, a second bootloader, and then further extended to a higher level software such as operating system and application codes. After the presentation, David is going to show you some demos. One of them is to run secure bootloader using the wolfBoot solution on MCX family. Another demo is to show you how to establish a secure connection through wolfSSL TLS solution. A secure connection is extremely important when the device requires secure update. We need to make sure the data transfer over the air or over the network are secure, and the data is coming from the origin of the source. The secure connected edge is experiencing unprecedented growth, design engineers are facing more challenges while designing products for edge applications. These challenges include processing power constraint, AI/ML acceleration, power efficiency, enhanced security, and more. To help engineers facing these challenges, NXP provides a wide range of MCU portfolio for the industry. The MCX family has 6 series. Each of them has targeted feature sets and use case. We create a scalable effect across these series. The C series is an entry-level MCX with the lowest cost option, with low power operation. The L series is eco-friendly, focusing on always-on battery-powered applications with minimal dynamic power consumption. The A series is for intelligent edge applications. It offers an optimized and cost-effective balance of performance and intelligent peripherals. The W series offers narrowband connectivity for point-to-point and networked communications with enablement for CB, Bluetooth LE, Thread, and Meta protocols. The N series offers multi-core performance, including NXP EIQ MPU, intelligent peripherals, and advanced security. And later this year, we are launching the 6th series, the MCX E series. It is focused on quality, reliability, safety for challenging environments in industrial automation, communication, transportation, and medical applications. Here are some key applications of the MCX family. It can be used for commercial buildings and industrial systems, such as sensor, access control, metering, and power management. Another application is for smart home and IoT, door locks, and thermostats. For general wireless connectivity, the MCX family can be used for e-bikes and scooter, and also for applications with Bluetooth, CB, and Thread. To ease the development for engineers, NXP provides the edge-first software development tools that includes secure provisioning tools for developer to configure the security features of NXP processors. With just 6 clicks on our secure provisioning tools, aka SCC tool, developers can build secure images for their applications in a minute. On the hardware side, we provide low-cost modular freedom boards for evaluation use. For code resources, we have over 160 example codes and tutorials on the Application Code Hub to show how to use our processors, especially on the security features and security enablement from our partners. Here are the example codes provided by wolfSSL running on MCX family. You can find them on the Application Code Hub. Now, let me hand it back to David to introduce wolfSSL solution. Over to you, David.
Thank you, Stella. Well, this is our wolfSSL product portfolio. Everything is built around our cryptographic engine, wolfCrypt, which is FIPS 140-3 and DO 178 certified. So DO 178 is safety critical certification, typically used in avionics. We also have a unique feature for asynchronous cryptography and also non-blocking cryptography. Our wolfSSL product has all the latest TLS and DTLS client server algorithms. We have a TLS inspection product called the Sniffer, which does passive inspection of TLS traffic. We have an MQTT client and a Sage client server, TPM 2.0 library, secure bootloader, which we're going to talk about much more. And we have an embedded firewall called wolfSentry, which is an intrusion detection prevention system. We have a PKCS11 provider that goes around wolfCrypt and wolfTPM to expose those things in the PKCS11 standard. We have a software HSM product called wolfHSM that takes advantage of hardware platforms that have a dedicated secure core or an area of the processor that is considered secure, and takes advantage of hardware, makes it easy for leveraging those features in wolfCrypt. We also have Wolf Engine and Wolf Provider, which are basically cryptographic plugins underneath OpenSSL. Our customers typically use our wolfCrypt FIPS under there, and it's a really easy way to get FIPS certification, in OpenSSL. We also have lots of different wrappers and utilities like Java and C#, Python. We even have Go and Rust wrappers, and we have TinyCurl also, which is an embedded version of curl. It's a smaller, condensed version of curl. So all of our libraries are licensed. We put it out GPL v2 or v3, and then we also have a commercial license available for anyone who cannot tolerate the GPL. All the source code is available for download at our website or GitHub, and it's fully out there in every way, so you can download it, try it out, and evaluate it. You get professional support directly from engineers like me. We also offer consulting services for integration of our libraries into your products or addition of new features. All of our libraries are written in C. In fact, even at the C89 compliance level, which is really difficult, and we provide a stable API interface. So any APIs that are marked with wolfSSL API or ABI, those ones are guaranteed to be forward compatible. We also designed it for portability, so there are no external dependencies. We provide a really nice abstraction layer for all of the things you might need for mutex threading time. We have build time support for disabling features and algorithms that are not required, which really allows for reducing code size, memory use, and there's also performance options on systems like, so all the Arm v7, Arm v8, Intel, we have assembly speed up options available. We have really great manuals, documentation, HTML, PDF. They're posted on our website, and they're actually generated daily from our open source project. So our TLS library has all the latest TLS 1.2, 1.3 client server. We also support all the old legacy TLS and SSL. Those are disabled by default. You can actually build wolfSSL with a minimum code size of 20 to 100 KB. Just depends on the configuration, and runtime memory use for a TLS connection is somewhere between 1 and 36. So there's a peak after the handshake. Typically, we only take 1 to 2K. We're also transport agnostic, so all of the transport, you can register read-write callbacks, and you can plug in any transport you want. But out of the box, we have lots of different examples for POSIX and LWIP. We support revocation, OCSP, stapling, CRL, certificate revocation list. We have Linux kernel module support for wolfCrypt and even wolfSSL. We have a huge compatibility layer, so over 1,900 APIs. So we could drop in our wolfSSL in place of OpenSSL. And we have, of course, all the ability to generate new certificate signing requests. And we have a certificate manager that allows you to validate chains. We support all the post-quantum hybrid and dual algorithm certificate schemes. And we have support for PKCS11, TPM 2.0, HSM, and secure elements like the SE050. We support all the latest algorithms in here, RSA, ECC, all the ed curve. This is just a small list, but I put it in here just for interest. And then we have all of our own implementations of the post-quantum algorithms like MLChem, which is Kyber, and MLDSA dilithium. And then we have the stateful hash-based signature schemes, LMS and XMSS. So those actually use a hash algorithm underneath. And these ones have been FIPS available in the FIPS boundary for a while. We're still working on adding those. And these ones we're also working on adding now. They just finally made those available within the last month or two. So we have our 140-3 certificate, which is 4718. So 4718 is the certificate number. for 140-3, and there's a couple more in the queue right now. Our sunset date for that is until July 2029, so that gives a nice long 5-year validity window. And we can support level 2 and 3 with customer hardware. We've also done DAL A, which is the highest level of safety critical certification for most of wolfCrypt. And we've also taken wolfBoot and wolfTPM through at DAL D level, I believe. We have all the latest CNSA 2.0 compliance. So the support for the algorithms that are mandated and the bit strengths. I wanted to have a slide on wolfTPM since I wrote it. It's my baby. So wolfTPM is the only TPM stack designed for bare metal. It doesn't require any OS, and there's no dependencies for any external components. It supports all of the TPM 2.0 modules, supports all the different interfaces and hardware vendors that are out there. It provides a stable wrapper API to simplify common use cases. It's designed for low memory use, so there is no heap allocation. All memories on this stack, which makes it really great for safety critical. It's very modular, so features can be disabled to reduce code size. It can be built in a standalone mode without wolfCrypt, but some features will be unavailable, like parameter encryption or importing external private keys. It actually has a built-in transport interface layer, and it supports parameter encryption with ASCFB, which is cipher feedback, or XOR, and there's also the HMAC and all that other stuff. And wolfBoot, which is our secure bootloader, again, written in C for bare metal use. So we support booting any type of OS or RTOS, but it itself is written for bare metal. It conforms to the RFC 9019, which is a firmware update architecture for IoT. It is a very small footprint designed to run on small embedded targets. In fact, many of our builds are less than 10 kilobytes. It's memory safe, so there's no malloc free. Simple partitioning and header scheme with support for multiple partitions. And we have a really nice hardware abstraction for adding new targets, which is, for example, bringing up the CPU and supporting the flash erase write. We have key generation and signing tools available, and those are very portable for across any type of platform. We support asymmetric public key-based verification using ECC RSA ED 25519 or ED 448. We support integrity checking with SHA-2 or 3. We use a public key-based root of trust with support for multiple keys. The loader handles the update installation between partitions, and it is power fail safe. And if there is an update failure, then it supports rollback. So we always keep the last known working version. And we also support version downgrade protection. We have full support for external flash memories and even dual bank swapping. It supports a bootloader self-update, which is not power fail safe, but it is a unique feature, so you can actually update the bootloader. We support encrypted updates and also encrypted applications. So if you have external flash storage, you can keep it that way encrypted. We can decrypt at boot time. We support AES counter mode and ChaCha20 Poly 1305 as the methods. We also have a unique feature, which is the differential delta updates. So we support patching only the differences between two versions. We have side channel and glitch attack mitigation, which you call armored mode. Right now, we have support for MCX A and MCX W series. We also have support for many of the IMX RT. And also with the Q or IQ and Layerscape, we have support for these. So these ones, the P and T series, these are PowerPC, and this Layerscape is an ARM V8, A57, and then some of the older Kinetis and LPC lines as well. We will be adding the MCX in and also the IMX 8. These are definitely coming. And it's very easy to add. Support yourself if you wanted to. I wanted to have a slide in here comparing MCU boot. So we support many more algorithms. We have much faster performance as far as the cryptography, thanks to wolfCrypt. We're OS agnostic. So everything is built to bare metal. So first thing out of boot ROM is wolfBoot. We're designed to leverage and handle using secure elements like a TPM or the SE050. The self-update feature, dual bank swapping, differential encrypted updates. These are all unique features. And you can even do FIPS 140-3 or DO178 certifications. Not to mention our attack mitigations for DPA and glitching. All right, so now we're going to talk about our wolfBoot demo on the MCX A153. So this board is the Cortex M33. and it can run at 48 or 96 megahertz. It has 128 KB of flash in 8K sectors and 32K RAM. So this demo just is a test app that shows a green or blue LED version that lights up based on the version. So for building, it's these simple steps. So we're a makefile-based system in wolfBoot. You simply copy the configuration file to a .config, and that has all the parameters for how to build wolfBoot, and then you just use make. It'll cross-compile and it'll generate wolfboot.elf, and then also a test app, and it will sign the test app, and it'll create a factory image. So these are some of the useful build options, like you can specify the signing algorithm you want to use or the hash algorithm. You can also turn on some of our single precision math speedups. So that's code written for a specific algorithm, which is much faster and smaller. The C version of our single precision code is typically, automatically on its own compared to the normal multiple precision math is probably like a 2x, and then the assembly version is somewhere like another 10x speed up. I mean, it's really incredible. So this was the way I set up the flash configuration. So I reserved 32K for the bootloader, and then set up 44 kilobyte application update partitions, and reserved one sector for the swap. So we always maintain two less known images. So then this is what the build size looks like for wolfBoot itself, depending on the algorithm choice. The smallest was RSA 2048 and SHA-256. I don't have on here some of the post-quantum ones. So we support all of the post-quantum algorithms in wolfBoot, like MLDSA, XMS, LMS, and the stateful hash-based signature schemes like LMS and XMS are actually quite a bit smaller because they're only using SHA-256, for example. Let's see. All right, and then flashing, after you get that factory bin, and you can just use the load bin command with the MCU link, and you can flash this factory image. So to test it, you would reset the board, and then on success, you'll see the D15 green LED will illuminate. So for testing the update process, this is what we would do. So we would sign the test app again with a version 2. And then there's basically a trick where we simulate what the status is expected to trigger an update. So we echo p plus boot to this trigger magic, and then we concatenate these two files, and then we can flash that to the update partition. So all that being said, once you reset, it'll go from version 1 to 2, and it'll switch to the blue LED being illuminated. Okay, so now we're going to talk about the wolfSSL demo on the Freedom MCX N947. So we've put out a few examples on the App Code Hub for wolfSSL. So let's break out of this slide. I wanted to show you this GitHub wolfSSL App Code Hub. So on this GitHub repository of ours, we have all the app code examples like an MQTT client, an SSH server, TLS server, and a TLS server that shows a TPM for the long-term key. All these examples are extremely well documented, easy to follow, and they're all using the VS Code plugin for MCU Expresso. Now, there's a couple ways to do it. You could just clone this and then import the project, or you can actually do it from within the extension. So I've opened up a new window in VS Code, which is actually, I'm using cursor. It's the same thing. And you can see I have the board attached right here. And I could either import the project, or I could do the application code hub. So if I go to App Code Hub and I put in wolfSSL, you'll see these 3 examples. We're working on the TPM one. But let's say I wanted to do the MQTT client with Zephyr. So I click on that, specify the location where I want it to be imported. So let's maybe let's put a new folder here called MCX examples in my home directory, and we'll say put it here. We can import that project, and it should go through and clone it and set it up. And this is the README that's there as well. Okay, so if you import, if you go to the App Code Hub and you add a project that way, then it will go ahead and clone all of Zephyr and all of the dependencies that Zephyr has within that project. If you actually go to import, so if you clone it and import it directly, then it'll let you choose your existing location for the Zephyr SDK. So this, I'm going to do the MQTT publish client with Zephyr, and I'm going to specify this repository and this version of the SDK. And you can see the link server's got access to my board there, and this is the project I'm going to do. So there's a couple of things you can configure it. There's a couple of ways to configure it, but for me, the easiest is always to go to the project.conf, and you can see the settings here. The code is underneath me. Let's see. And you can specify things like if you want to use DHCP and what TLS version. Let's see. I'm going to leave all this alone because it's set up for DHCP. And then there's different build options for wolfSSL and for MQTT. So now we're just going to do a build. There's the ability to do a, oh, I'm in the wrong one. Go back here. So this is the project, and I can do a build project. So this will use, Zephyr uses West, and it's one of those multi-threaded kconfig type systems. So it'll generate and build pretty quickly. While that's building, what I'm going to do is I'm going to open up a serial monitor over here, and I'm going to connect it to the USB modem at 115.200 with the CRF line in. I'm going to start, and this will give me the console. I think I have an old example loaded up on there, but we're going to load up a new one. When this is done, we're going to load up a new one. So once it's done building, you can actually just click this button to debug, and it will, yep, so it'll connect up to the board, and it will flash it, and it will attach GDB debugger within VS Code here, which is really nice. Let's see if I can clear. Okay, yep, so it got me a breakpoint right at main here, and for example, if I step over this line, it should pop out right there, so it's great. I'm going to go ahead and run this. It should start up the network, and then it's actually going to, so it's first going to try to obtain an IP address, and then it's going to do an MQTT publish up to AWS. There we go. And it did it. Finished the test there. Can't read the bottom of it, but it's set up the IP with DHCP, set the time using an NTP server. It connected. I don't have the certificate authority set up, so we allow the certificate regardless of that. We connect to AWS, and then we publish to this test topic a simple publish test message, and that's it. So that's really simple. It shows you how easy it is. Once you get this MCU Expresso extension installed to get up and running. Zephyr has all kinds of neat features, but I'm not going to go into detail of those. So let's go back to the slides. Okay, this last slide, I wanted to cover our partnership between NXP and wolfSSL and how together we're delivering a robust solution for our customers. We're keeping up with all of the regulations and standards and providing solutions for those. We've extended the ecosystem to support really nice integrated security on the secure boot side and TLS with all the latest algorithms, including post-quantum. We're enabling security and open source using FreeRTOS and Zephyr with, for example, the App Code Hub and VS Code. And this is all portable across different. I didn't mention it, but the wolfBoot supports also a hybrid post-quantum scheme. Hybrid meaning where you have well-known existing algorithms like ECC along with post-quantum. And we support that as well inside the TLS protocols for both the ephemeral key that's used in the shared secret and also the certificate supporting dual signing. So now we're going to open up for questions. If you have any questions after this that you didn't get to ask, you can just email facts@wolfSSL.com. That's FACTS at wolfSSL.com. So now let's answer some questions.
Wonderful. Thank you so much, David and Stella. Jumping right into the questions, is there any resources that you can provide to help us with the CRA?
I can take that question. Yeah, so CRA is a hot topic right now because of the enforcement is going to be happen very soon, the full enforcement. So NXP, we have doing a lot of preparation to help our customer to prepare for the CRA certification. So we have right now we are driving some like application notes that's showing some mapping from our processor, MCU and MPU on those security feature. How can we address each of the requirements that required by the CRA? And we are also preparing some like FAQ on our webpage. I know that there are a lot of questions from the market about the CRA, their group, and also some update about the CRA. So we are preparing a page about the CRA that some FAQ can be found on our website.
Yeah, and I want to add one more thing.
Mhm.
All connected products need to comply to this EU by 2027. Security needs to be early and a core part of the design, including secure boot and secure update. There has to be a published software bill of materials, and the security support must be provided by the manufacturer for a minimum of 5 years. We will be doing a blog, so watch for that. And I also wanted to say that because we're open source, it's also so one of the things is you have to have a third-party audit of the security, and the fact that wolfSSL products are open source makes that much easier to do. So yeah, but watch for some more information coming on that.
Wonderful. Is there any plan to run wolfSSL PQC solution on NXP devices?
Yes, and we can already run all our post-quantum algorithms on any NXP device. And for ARM processors, we support assembly optimizations too. We do have an upcoming joint webinar with NXP and Crypto4A on August 27th at 9 a.m. Pacific time. And there's another one on September 10th that will talk about post-quantum algorithms on the NXP, specifically this N943 part. So watch for those.
Wonderful. How can your products support industrial applications, in particular for IEC 62443 compliance?
Yeah, so NXP, we have a lot of customer in the industrial market, and one of the biggest concern from the industrial customer is the 62443 compliance. So as I mentioned in my slide, for our secure products, MCU or MPU, or even the secure element, we design our products with security by design. We follow the 62443 standard. And also when customer, they need to compliance to the, they need to compile compliance to the 62443. We also list out some of the requirements on the system level. We address each of them with the security feature of our processor. For example, the secure boot, secure update, or even the runtime security that wolfSSL can also help with. And we have some like examples on our SDK, and also some application notes that you can find from our NXP website.
Wonderful. Is it possible to implement just the same wolfSSL features with FRDM RW612 board, the Cortex M33, or the Bluetooth LE?
Yes. Yes. In fact, I'm holding a Freedom RW612 board right now, and it is on our roadmap to officially add support very soon. However, if you wanted to take that on yourself, it's quite easy. All the codes in C, it's super portable. You might have a harder time if you wanted to offload some of the cryptography to the hardware. That usually requires a little bit more work. But just getting either wolfCrypt or wolfBoot or even wolfSSL TLS running on that target should be pretty trivial. And if you go about doing it yourself and you have any questions, we provide free pre-sale support. So you can always email support@wolfSSL.com, and we'll support you through it. So
Wonderful. Well, I think that covers all of the questions. Thank you, David and Stella, for hosting an informative webinar. Thank you to everyone for joining. I will email a copy of the webinar recording and PDF slides. You can keep up with our upcoming events, meet our team in person, read our blog posts, and get the latest wolfSSL updates by following us on X, connecting with us on LinkedIn, and subscribing to our YouTube channel. If you have any questions, please reach out to us at facts@wolfSSL.com. Thank you again, and we look forward to seeing you on May 28th for our webinar all about DO178. Thank you all.